All right, we're going to finish up this desmos activity on this video. We're going to take everything that we understand about end behaviors and max, mins, and numbers of turns and try to be able to write the function that matches this. So it says write a polynomial factor form that matches the graph. So the first thing I'm going to do is look at the x-intercepts and write my factors that match the x-intercepts. So I have an x-intercept at -1, so x plus 1 be one factor. I have an x-intercept at 0, so just x will be another one. And then I have an x-intercept at +2, so x minus 2. If you notice, I put the x in front. It's just the way you write it. If you just have an x-intercept at 0, that just means you're going to have an x out in front. All right, and that matched up. My a was 1. Everything matched. I didn't have to change the end behaviors because my leading coefficient is positive. The right end behavior is going up. Okay, it's a degree of 3, so the opposite end behaviors, everything worked out nicely for that one. Okay, on this one I have an even degree. Looks like it's a 4th degree. I got 3 turns. I got 1, 2, 3 x-intercepts, so we know that that's going to bounce. So it's going to have an exponent of 2. It is going to be a 4th degree. So again, we'll start with our factor. So I know it's going to be x plus 1 because there's an x-intercept at -1. I'm going to come back and address that later. It's not done yet. Then I have one at +1, so x minus 1. Parentheses going on here. And then my last one's at 2, so x minus 2. Okay, and so you can see it's not right. Why is it not right? Well, 1, okay, it's got to bounce here. So that means I got to put a 2, okay, as my exponent on that factor. So now it bounced, okay? So I got even now. My end behavior is going up. I need them to go down, so that means I need to make my leading coefficient -1, and now it matches. All right, so here, again, I've got 4 x-intercepts. They all go through, none are balancing, so I'm just gonna go ahead and write those in. All right, so I have one at -2, so x plus 2. I have one at -1, so x plus 1. I have one at 1, so x minus 1. I have one at 2, so x minus 2. All right, so everything's looking good except that I need to stretch it out. It's not growing fast enough, so my leading coefficient needs to change. So let's try doubling it because it's going from 4 to 8. That looks like that should work, and it does. All right, next one. All right, so now we got an odd degree because the left end behavior is up, the right end behavior is down. Right end behavior is down, tell me leading coefficient is going to be negative. I've got a bounce, I've got a point of inflection, and I've got a bounce. So I've got a lot going on in this one. All right, so let's go f of x. And I know my leading coefficient is negative, so I'm going to throw a negative out in front. All right, and then let's start with this x-intercept right here at -1, so that's x plus 1. And that is going to bounce, so I need an exponent of 2. And then I got an x-intercept at 1, so that's x minus 1. And that's got a point of inflection, so that's going to have an exponent of 3. And then I've got one at 3, so that's x minus 3. That bounces, so I need an exponent of 2. And now my graph is too steep. Okay, so now I need to shorten it up. So let's just start with 1/2. And that happens to be it. All right, so that one had a lot going on, right? Points of inflection give you an odd exponent, okay? A balance gives you an even exponent, right? Right coefficient going down gives you a negative lead coefficient. All right, list the zeros, include multiplicities, okay? So I've got a 0 at x equals -2, at 0, and 1, but 1 has a multiplicity of 2. I just put next to it times 2 for the multiplicity. You could write out the word multiplicity of 2 or just, right, because it balances, so I know that it happens twice there. Okay, what is the y-intercept? The y-intercept is just 0, 0. The left end behavior is going down towards negative infinity. So I'll just type in negative infinity. The right end behavior is also negative infinity. Again, you get the infinity symbol. I'm just hitting the little square root down here, type math, and I type the word infinity and it changes it to the symbol. The leading coefficient positive or negative, that's negative. And I could know that because my right end behavior is going down. Is the degree even or odd? And this is even. And I know that because the end behaviors are the same. All right, sketch with the graph. Sketch the graph. So here, okay, I have an odd degree, and I have a positive leading coefficient. So my right end behavior is going to be going up. My left end behavior is going down. Okay, I know that. Oops, I just did that wrong. Okay, so I have 3 positive zeros. So I'm going to have 3 x-intercepts. Okay, now on the positive side, I have a negative 0 with a multiplicity of 2. So I'm going to have 1 that's negative over here. All right, and I have a y-intercept at negative 5. And since it has a multiplicity here, so as I draw this up, it's going to hit that, right? And it's got to bounce off. Right? Now I know it's got to come back through the y-intercept. It's going to come through there, change direction, change direction. Whoops, kind of sloppy there, but that'll work. All right. So we know why is it balanced? Because it said multiplicity of 2. Got a y-intercept at negative 5. All right. As 3 over here could be anywhere, just 3. It's got to go through it, back down, back up, and then end behavior is going up there. So there you go.